Lesson 2, Configuring our Failover Cluster. So in this chapter, we're going to be talking about things like configuring a quorum, looking at the cluster and cluster networking. It can also involve restoring both a single node plus the cluster, cluster storage, upgrading, optimizing, configuring clusters without network names, and generalized storage space. So, first portion is understanding failover clustering. A failover cluster is a set of servers, normally between 0 and 64 depending on the clustering technology, that work together to increase the availability of a service. So for example, if you ever wonder, Google.com is a perfect example. When you go to Google.com, even if you go to just one of the IP addresses for Google, in reality, you're not going to a single server, you're going to a cluster. That way, it's probably thousands of servers working together so that the responses can be as quick as possible. So again, the availability of that service or resource is increased. So the cluster servers, normally called nodes, are connected through a network connection, whether it be a physical or a virtual connection, and by software. If one of the nodes fell, another node begins to provide services, and this is the process known as failover. So if we have at least two servers in a failover cluster, if one fails, the other one auto picks up the load. Now that's different from load balancing. Load balancing, we've been splitting the load. With failover, we have one that's actively doing it, and we have a passive one. That passive one only ever becomes active if the primary goes down. So failover clusters can be used for a wide range of resources, services. They could include things like a database or Exchange or SQL, lots of different network services. So again, we already talked about the active passive cluster, and this is the most common type of cluster. In an active passive cluster, both servers are configured to work as one, but again, only one is active at a time. If the active node goes down, then the passive, after X amount of time, becomes active. Failover clusters. To create a failover cluster using Server 2012 R2, you have to have at least two servers, and they have to at least meet the bare minimum requirements for Server 2012 R2. That's kind of understandable since you're installing Server 2012 R2 to put them in a cluster to begin with. So the nodes should have identical hardware and hardware components. That's not a requirement, that's more of a just recommended. In addition, the server must run the same version and edition. Again, that's not required, that's just preferred. Nodes should have the same hardware version, 64-bit, and the server should also have the same software updates and service packs. You want to get these servers as close to one another as possible. Okay, so now that we talked kind of what a cluster is, we have to talk about how we do some resources. So when you create a cluster, you assign the network resources to the cluster, which can be enabled or disabled depending on if the nodes are active or deactivated. Every cluster has an assigned cluster virtual IP. This includes the network name and IP address assigned to the cluster as a whole. The cluster services are services or applications that are made highly available by installing them on the failover cluster. Clustered services are active on one node, but can be moved to another node, hence the active-passive failover. Cluster resources is the most basic and smallest configurable unit that can be provided to a service to a client, or an important component that makes up the cluster. This kind of depends on what do we want to make available. It can be a network application, it could be any type of resource, it could be many things. Dependent resources. This is a resource that is dependent or depends on or is required by another resource to operate. Because a network name must be associated with an IP address, the network name is considered a dependent resource, because again, it's dependent on the IP address. To perform a graceful failover from one node to another node, the dependent resources are taken offline before the resources upon which they depend on are taken offline. When the resources are brought online, the resources that are required for the other services to function are brought online first. Again, when we're talking a failover state, we're talking this is happening fairly fast. Nodes, we already said that nodes are the servers that make up the cluster. They have an association with the cluster resources. And again, we're looking at 64 nodes, and that can run 4,000 virtual machines on each cluster. While Server 2008 supported only 16 with 1,000 virtual machines. Other major failover components are network, cluster storage, clients, and cluster services. Network, because that's what's going to allow communication, and that's going to be within a cluster. We're looking at public, private, and a public and private hybrid. Cluster storage is a storage subsystem that is shared between the cluster nodes, usually connected via either iSCSI or fiber channel. That way, everything is shared through centralized storage. Clients, obviously that's where our end users are coming in that are going to be using our cluster service. That cluster service is the actual server that manages and coordinates the cluster resources, which does ultimately provide the high availability. So the failover cluster uses IP-based protocols. It's pretty common in today's Ethernet-based networks. They can be either IPv4 or 6. And again, we already said that these types of networks are going to be private, public, or some type of public-private hybrid. Private network is used to connect to the node just with each other. Public is going to be used between the nodes and the clients. And some type of public and private network is used to communicate with external storage systems. Similar to the NLB, a cluster, a failover cluster has full connectivity and communication with one another, and it does send heartbeats. Again, that way verifying that each machine is up and active and running, or each node is up, active, and running. Because clusters usually need access to shared storage, the cluster should have a public and private network to communicate with shared storage. Again, we're looking at iSCSI or fiber channel. Normally using some type of dedicated storage. So if we're looking at fiber channel, we're looking at a dedicated fabric for storage, or iSCSI, or any other form of shared storage. So in Server 2012 R2, our failover clusters use a virtual network adapter called a Microsoft Failover Cluster Virtual Adapter. And to communicate between the nodes in this cluster, it does it with a APIPA. That's right, a 169.254 address. Even though they're not routable, this allows for local communication between nodes. Or if we're dealing with IPv6, FE80::/ with a /10. So again, a similar type address that's not routable. The Microsoft Failover Cluster Virtual Adapter is used as an alternate network if the private network or connection does fail. Initially, installing a failover cluster is a three-step process. We install the failover cluster feature, we validate the cluster configuration, then we create the cluster. How do we create the cluster? Is we load the failover cluster manager. And again, we're looking at most failover is going to use some type of shared storage, and normally it comes in a few different types of flavors. Shared SAS, iSCSI, Fiber Channel, or Fiber Channel over Ethernet. Those are all common ones. Shared disk. This is for the disk types, uses basic, not dynamic. You prep the file system in TFS. You prep the partition, whether it be MBR or GPT. Either one doesn't matter here. The storage devices must follow the SCSI Primary Command 3 or SPC 3 standard. This is basically just a support persistent reservations. So a storage device can only be assigned to one specific cluster, and normally this is by just assigning a LUN or maybe zoning. And so that's our shared guide. So here we have our disks and our available clustered storage. So traditionally, a single node controls a LUN on the shared storage. Starting with the Server 2008 R2, Windows can use a clustered shared volume CSV, which allows multiple nodes to share a single LUN concurrently. You see this very common now within virtualization and shared storage. So a LUN on a SAN actually being shared by multiple physical hosts that may host where VMs are stored. That's very common now. So with CSVs, a clustered role can fail over quickly from one node to another because, again, you don't have to worry about drive ownership, dismounting, remounting volumes. It's just all of the hosts have access to that same storage. So it's just a matter of bringing up the processes and resources on a new host. So after a disk has been added to a CSV, the volumes appear as clustered shared volume file systems, or CSVFS. Have to love the acronyms here. CSVs in Server 2012 have the following improvements. Multi-subnet support, so that allows you better throughput for our small or server message block. Multi-channels that allow the network adapter to support remote direct memory access, RDMA. BitLogger, newer forms of SMB 3.0 storage. It allows for the integration with storage space, as well as allows Server 2012 to scan and repair volume. The nice thing is, with Server 2012, it can provide additional functionality for our CSVs. NTFS, or Resilience File Systems, is one of the new ones. CSV applications can also include clustered virtual disks. VHDs are very popular in Hyper-V, as well as scale-out file shares that can be used out with scale-out file server cluster roles. Okay, so to use CSV, the disk or storage space must be a basic disk. If you want to use shared space for a CSV, Server 2012 supports simple space or mirror space, while Server 2012 R2 can also be configured as parity space. Essentially, it's going to be different forms of additional storage or software type RAID. On all nodes, the drive letters for the system disk must be the same. The NTLM protocol must be enabled on all nodes, and this is done by default. A CSV cannot be used as a quorum witness disk. In addition, CSVs do not support the following. Windows Server 2012, you cannot enable data duplication or compression. And in Server 2012 R2, you cannot enable compression on CSVs. So a quorum is used with a failover cluster to determine the number of failures that the cluster can sustain. If a quorum, the majority of the votes, is not reached, the cluster will stop running. Each voting element contains a copy of the cluster configuration and the cluster service work. So this will work to keep all copies synchronized at all times. If you have an odd number of votes, the quorum witness does not have to vote, and if you have an even number of votes, the quorum witness has a vote. In addition, if the witness resource is offline or is filled, the cluster sets the witness vote to 0 or no. So, a little bit more about quorums. In Server 2012, you needed to configure a witness and manually adjust the quorum configuration for the node membership. That way you'd always have an odd number. Also in Server 2012, you had to run the validate quorum configuration validation report to use to be able to view the voting status, or you could use PowerShell to view the voting status. So the quorum configuration for Server 2012 is node majority, node and disk majority, node and file share majority, and no majority, disk only. So when we're using a witness disk, the disk must be at least 512 megabytes. It must be dedicated for the cluster use and not assigned to a cluster role. It cannot be a volume that is a CSV. With Windows Server 2012 R2, the CSV ownership is automatically distributed and rebalanced across the failover cluster nodes based on the numbers of CSVs that each node owns. Ownership is automatically and it's rebalanced when a CSV failover occurs, or if a node rejoins the cluster, or a node that is added to the cluster later. Here's an example of our quorum. Moving on to storage space. So Windows Server 2012 and Server 2012 R2 can group local disks, whether they be USB, SATA, or SAS, into storage pools, and then create virtual disks called storage spaces from the available capacity in that storage pool. Again, very similar to resource allocation with virtualization. Our storage space can also provide resilience, such as using mirroring or parity, as well as scalability. When you're running Server 2012 or 2012 R2, you can deploy cluster storage space by using storage space in failover clusters to provide that resilience. It also provides high availability and a way to cut costs and become more cost efficient. The storage space, you cannot use the storage space to host a Windows operating system. You can use the cluster storage space that can help protect against physical disk failure, data access failure, data corruption, or even just a physical node availability issue. By using the CSVs, you can combine the storage access into a single namespace, which all cluster nodes can be accessed through that same namespace. If you're looking for a dumbed down version of this, in Windows, like 7, 8, 10, any version like that, you actually end up with libraries, the document library. And that's just really a namespace because you can have multiple folders that all are part of the namespace document that aren't in the same location. Pool nodes. Here's an example of our pool nodes. We can actually organize pool nodes as we see fit. So with 2012 R2, it introduced an Active Directory detached cluster section. By using Active Directory detached cluster, you simplify the process of deploying, managing, maintaining our failover clusters. While Active Directory detached clusters use Kerberos for authentication, for inter-cluster communication, the cluster nodes must still be joined to Active Directory. However, when accessing the cluster network, name uses NTLAN Manager, or NTLM, for authentication instead of Kerberos. When you create an Active Directory attached cluster, you register the cluster network name with the network names of clustered roles to your DNS server. That way, without creating a computer object in Active Directory, you can access the name of the cluster is the purpose. Before you create the failover cluster, you must make sure that all servers that you want to add as the clusters meet very specific prerequisites. They all must be running Server 2012 R2. They all must be joined to the same Active Directory domain. All servers must have the same failover cluster feature installed. All servers must use the supported hardware, and collection of servers must pass all cluster validation tests. Essentially, the servers have to be the same, be on the same domain, and have Server 2012 R2 installed. When a failover occurs, intentionally or unplanned, the failover attempt will consist of the following steps. The cluster service takes all the resources in the instance offline in an order that is determined by the instance dependency hierarchy. The cluster service transfers the instances to the nodes that is listed next on the instance list of preferred owners. Third, if the instance is moved successfully, the cluster service attempts to bring the resource back online. So to drain the roles, meaning to change the roles to other nodes gracefully, we can right-click on a node, click pause, and then click drain roles. To resume a node, right-click on the node, click resume. It should fall back. So to stop a cluster service, you can right-click on it, click stop cluster. But again, this is mainly things that you can see how to do when you're actually doing it on the cluster. For that, we're going to do lab videos. For maintenance tasks, to manually change a shared disk or role, we're going to talk about that in our next lesson. But you can right-click on the shared disk or role, and we can move it, or we can select the best possible node, or we can manually set it. Here is our failover cluster manager console. And here we're going to see that our cluster 01 is part of our domain. Now let's move on to our cluster aware updating. This is a good one. So starting with Server 2012, they implemented this cluster aware updating, or CAU, and this lets administrators update the cluster nodes automatically with little or no downtime, especially if we're using Hyper-V with live migration. You can use CAU if you're doing one of the following: remote updating or self-updating. Here we have our wizard that allows us to set our update schedules. Here are some of the advanced options that you can set. Upgrading our cluster. So if we're looking at replacing a cluster node or to upgrade to a newer version of Windows, we can migrate the cluster roles or services from one cluster to another. This way we can go from 2008 to 2008 R2 or to 2012 or to 2012 R2. Migrate these roles and configure in one of the following two ways. We can migrate from an existing cluster to a new cluster, or we can perform an in-place migration on a two-node cluster. Kind of just depends. So one of the last things we have to talk about is troubleshooting and backup. So troubleshooting problems. So when there's a problem, we need to understand some basic items. Identify the perceived problem by collecting and documenting the symptoms. Determine whether the problem is with the entire cluster or a specific node. When collecting additional information, make a list of possible problems so we can prioritize, and that way we can focus on the higher ranked repairs. Next, complete and test the repairs in a hierarchy model or a structured model. Finally, document. Backing up our cluster. So if we're assuming that you have installed Server 2012, the server backup feature, you can perform a backup. The cluster needs to be running, and you must have a quorum. The cluster service keeps track of the cluster configuration. That's already been stated. So when a change is made, it's replicated to the configuration of all clusters. So, how do we restore a cluster? We can restore it one of two ways: authoritative or non-authoritative. A non-authoritative restores the information that was performed when originally backed up, but it is overwritten by current information stored on other cluster nodes, as opposed to authoritative, which restores the information that was performed originally backed up, but is marked as current and authoritative configuration. Then it will overwrite what's in previous nodes. And that's actually for this chapter. I wanted to thank you guys and hope you have a good day.